Hi, my name is Molly Vick, and today I will be going over my Physics 2212 Lab 3 about the magnetic field of a bar magnet. So I will start with an introduction including key ideas and fundamental principles. Next, I will discuss the lab setup and procedures and discuss my observations. Then we will look at my data in a spreadsheet along with my calculations. We will then take a look at my GlowScript code, including pictures of my code and the program output. And finally, we will look at the results and compare my experimental data to the computational GlowScript model results, and I will discuss the what if questions and why questions. Here is a look at the fundamental formulas and ideas used in the lab. First, we have to understand that a bar magnet is treated as a magnetic dipole. So we need to know the magnetic field of a magnetic dipole on its axis and know the magnetic fields could be superposed. We also will need to know how to linearize data in this lab. Looking at our formulas, we have the Biot-Savart law. We will also see that the first two formulas on the right are the magnitude of the magnetic field due to a magnetic dipole. We'll use this to calculate mu. The third formula has to do with linearization and will be applied to our calculations of the lab. The last equation we will use in our computational model to approximate the magnetic field of the dipole at any location. To introduce the lab, we are going to measure the distance dependence of the magnetic field due to a small bar magnet. Our system is the bar magnet and our surroundings is everything else. Now we will look at these observations. The first and fourth observations are the only ones that apply to this lab. I noticed that when the magnetometer was far from the magnet, Bx was close to 0, and as it was closer, it increased as expected. Here are the first steps for the procedure of the lab for locating the magnetometer. This walks you through the steps along with visuals of the setup of the lab. Here is the second part of the lab setup where we measure the magnetic field. You can also see the visuals of the setup and the steps listed here. Here is my spreadsheet of the experimental data where I have my raw data and my graph of ln Bx versus ln R. At the bottom, I have my net magnetic field 45 degrees off axis from the dipole. We will use this data to perform some calculations. Here I use the linearization in the graph from my experimental data to calculate n and k. I use the slopes of the graph to find n and the y-intercept of the graph to find what k is. Now I set these equations equal to each other and plugged in r, k, and n for my previous calculations to solve for mu. I got mu equals 2.136. So now we'll look at my GlowScript code. I first defined a function to calculate the magnetic field due to a dipole with a given observation location and dipole moment. I set the locations for 6 points to visualize the magnetic field. 2 are on dipole axis and the other are perpendicular. Next, I coded errors for each of the 6 points in the code here. Last, I did the same thing for the 45-degree angle off axis down here. And so now this is my code output. The orange arrows represent the points on the dipole axis and the blue arrows represent the points perpendicular to the dipole moment. The purple shows the off-axis magnet field with the 45-degree angle. The arrows are scaled to the magnitude they represent. The text output shows the magnitude of the 45-degree angle and the distance d. This is important in our comparison. Now we will compare our results. We will see that our distance in our calculation and our output code is the same. d equals 0.254 meters. However, the magnetic field shown as a vector had different results in our computational model and our experimental model. Some possible sources for error could be electrical equipment nearby, failure to align the phone with the north before starting, or having steel or iron objects near the smartphone. So now I'll answer the what if and why questions. To start, if we hadn't compensated for magnetic north and laid thermometer stick at any intermediate angle with respect to Earth's magnetic field, our x component of my results would change, orienting at magnet north zeroes out the x component. To answer the next question, the measurements would differ because the magnetic field would increase. That is it for my lab. Thank you so much for watching, and I hope you have a great day.